We're going to look at a first order linear differential equation, which will be solved by use of an integrating factor. The first step is to put it into standard form, which is y prime plus something times y equals something else. This first something is called p, the second one is called q. Now I need my integrating factor, which I will call u, and it is always e to the integral of p of x dx. In other words, e to the integral of 3 dx, so e to the 3x. You may notice that I'm not putting a plus c on this, and that's because the plus c ends up getting absorbed later on. It's not worth the trouble to put it in at this stage. Now, I'm going to go back to my differential equation, and I'm going to multiply the entire equation by this integrating factor. So I'm going to get y prime e to the 3x plus 3y e to the 3x equals e to the 6x. Now, the reason for this is because this has now turned the left-hand side into the product rule to find the derivative of y times e to the 3x, because it's derivative of the first times the second plus first times derivative of the second. Okay. So now, if I integrate both sides, the integral and the derivative cancel each other out, leaving just y e to the 3x. I do need to integrate the e to the 6x, so the e to the 6x, and then divide by the 6, which is the derivative of the inside. And I do finally put the plus c in here. Lastly, I need to solve my equation for y, which involves dividing both sides by e to the 3x. So I get 1/6 e to the 3x plus c e to the minus 3x as my final answer.